Dear colleagues, welcome to our EHJ Dialogue. The successful story of our dialogues continues. I remind you that our dialogues are live streamed, not only in YouTube, but also in Twitter. I remind you also that our dialogues are very interactive, so please ask questions. You can raise your physical hand or your virtual hand, and it's really our pleasure to involve you in our dialogue. Today, we have a very, very interesting dialogue with a famous guest, who is Peter Schwartz, who is also editor of the European Heart Journal. And I will host him with Perry Elliott, who is the executive editor of the European Heart Journal. And we have a very exciting title for this dialogue, From Long QT Syndrome to Precision Medicine in Channelopathies, a 50-year journey. So this is really a long story, so be ready to listen to this fantastic story which started 50 years ago. And now it's my pleasure to ask Perry to introduce Peter. Please, Perry.
Filippo, thanks. So once again, a great pleasure to be involved in this dialogue. And Peter, a really great privilege to have a conversation with you. So as always, we always say this, but I think it really is true in your case. You don't really need a great deal of introduction. But perhaps the most important fact about you, of course, is that you were born in the UK. But for some reason, you rapidly left and you became one of the giants of Italian cardiology, where, having qualified from the University of Milan, you went on to specialize in cardiology. And that's essentially where you remain as director of the Center for Cardiac Arrhythmias of Genetic Origin. But of course, you're also a man who crosses countries and crosses continents, and you have important positions at the University of Stellenbosch and in Cape Town. Your career is, you've had numerous leadership roles, both within Italy, for example, leading the Italian Cardiac Society, but also internationally, where I think you've made really important contributions to both the way in which we think about arrhythmias, arrhythmic drugs, and the management of complex arrhythmia. I mean, you were one of the leading lights in the CAST trial, cardiac arrhythmia suppression trial. And of course, you were one of the key players behind what we then called the Sicilian Gambit, about a new way of classifying antiarrhythmic drugs. But of course, I think everybody will know you now as someone who spent your entire career focusing on the autonomic system as it relates to the heart, and particularly important diseases that cause sudden death in young people. And I think your contributions to long QT syndrome in particular are, I think, certainly for those of us in the inherited cardiac disease community, I think your greatest contribution. So we're really looking forward to an exciting conversation about you, your past, and of course your future. So Peter, maybe we can start at the beginning. I mean, is it really true that you started off as a hypertension doctor?
No, I started working with Professor Zanchetti, who was a world leader in hypertension, but who also was a physiologist who started his work with the central nervous system. I started working in his institute because it was one of the very few in Italy in the late 60s, mid-60s, that was publishing at the top level everything they were doing. So I started working in his institute. I actually never worked on hypertension, which I always regarded as a rather boring disease, where the maximal excitement comes from shifting blood pressure by a few millimeters up and down. So I became interested in sudden death, where people drop dead all of a sudden. And to work with him was very important because he had an open mind, never pressured me to work on hypertension. And actually, I began the initial work with Alberto Magliani, who was my first mentor.
And you've told us how your story with long QT syndrome in particular began. And I think it's quite unusual to remember the very first patient that stimulated the rest of your career. Would you like to maybe tell us a little bit about that?
Yeah, it was January 1971, when we had this little girl, 8-year-old, her name was Agostina, who came to us because her sister, who was 18-year-old, had died suddenly during a live TV program. And she went on all newspapers because that was seen by everyone in Italy at that time. And when the girl came to us, brought by her mother, it was because she had fainted as the same way of her sister. Whenever she was getting emotional, or she was running, or she was frightened, she would lose consciousness. So there was a clear relationship between the sympathetic nervous system and her condition. But we had no idea about the diagnosis. I mean, it took a few months going back to the library, talking with people before we made the diagnosis of a long-QT syndrome. And her QT interval was indeed a very, very, very long one. She happened to end up in one of the 4 beds at the University Hospital in Milan, where I had a little bit of responsibility. I mean, I was no one. I mean, I was just a very junior doctor with no experience whatsoever. And at the beginning of our studies, one day we wanted to have an exercise stress test performed. And when the girl entered in the room, she was frightened. She said, I feel sick, I feel sick. So we laid her down with an ECG. And her T waves were going up and down, up and down. Now, I was never very good with electrocardiography, so I had no idea on what was going on. I turned, I was smiling, but that is true. I'm not good. I can measure the QT interval, though. So I turned towards the senior cardiologist and asked him, what is this? And he said, these are very ugly T waves, which is not a very scientific explanation. So I went down to the library, eventually realized that the phenomenon was called T-wave alternance. And looking at the index medicus, because in those days that was the only point of reference, at my institute, we had the index medicus from 1920 to 1970. I checked every single month for the 50 years. And there were only 7 cases in the entire world published on T-wave alternance, but the few cases described of long QT syndrome, most of them were showing T-wave alternance. So I started thinking that there might have been a relationship between the two. And this was the beginning of the thing, because once I was able to reproduce T-wave alternance and prolongation of the QT interval, we decided, based also on some other studies, to perform left sympathectomy in Agostina, which we did in March 1973. And she stopped completely having any attack, any problem. She died because of an accident 6 years ago. But we developed a very important personal relationship. She came to see me and we were visiting her every single year. She became a sort of a daughter, and she said that I was a sort of a second father. And as a matter of fact, as I wrote once, our 2 lives crossed at one point and had a major impact on both of them, on both of us. On one hand, I probably saved her life, and on the other, she almost unconsciously forced me to change my research activity and to focus on the long QT syndrome, with results that I have never regretted.
Mm. Was she the first in the family to have this?
No, she was the second. The first one was her elder sister who died suddenly, and that was what started. But she also has another sister, a younger one, also one who suffered cardiac arrest. We did sympathectomy when she was 5-year-old. She's perfectly fine now. I see her every single year.
And if you think back to that experience, I mean, and compare it to how we manage and diagnose such cases now, I mean, is it a complete miracle, or are we still missing these kind of cases? I mean, what do you think we've learned from Agostina over the past 50 years?
Well, we've learned a lot, and a number of things are different. But in those days, we were really in an unknown world. We had no ideas on what could be done. We had no ideas about therapies. We started using beta blockers because there was a relationship between the triggers for her syncope and loss of consciousness. But that was all we knew. I was lucky because working at my institute, We were doing clinical work in the morning until 1 o'clock. Then we were entering in the research laboratory. Our main thing in the initial days was to record single fibers in the sympathetic and vagal nerves. And that offered me the possibility of doing experiments, trying to reproduce what she had. And one day, and that was probably the most exciting moment in my life, I was able to reproduce T-wave alternance by stimulating the left striated ganglion. So both the prolongation of the QT interval and this very unusual phenomenon could be elicited by stimulating the left-sided sympathetic nerves, which meant probably that removing them, we would have afforded protection. And that has guided my research throughout the 70s, when I explored mostly in dogs, in a variety of sudden death models, the impact of left cardiac sympathetic denervation on the probability to develop arrhythmias.
So that discovery of if you like, the neurological components of this was critical, wasn't it? What are the other landmarks in the story of long QT syndrome, do you think?
Well, clearly the efficacy of beta blockers was a main point. The understanding that removing left cardiac sympathetic nerves, I think, still is a major issue. There are unfortunately countries in which this surgery is not done. Mike Ackerman started 20 years ago in the United States, which has an important impact in the development. I mean, for almost 30 years, I was doing it by myself practically. I was traveling with my surgeon all over the world and doing it, but it was a little bit difficult because it seemed that it was a personal obsession. Now, finally, it is evident that the procedure, which is now much simpler because with thoracoscopy, it takes 40 minutes, 3 holes under the axillary without opening the chest, is a much easier surgery. And it is important because it represents an intermediate step between failure to beta blockers, when that happened, and the implant of an ICD, which has a lot of significant adverse effects. So that is a major point in terms of therapy.
And where do you think the genetics fit in this story over the past 50 years? How did that change the way in which we think about these diseases?
A lot. I mean, for a variety of reasons. On one point, it has strengthened the diagnosis. Of course, we were making the diagnosis before 1995, but certainly genetics have helped. What we learned at the beginning of this millennium, with a different impact of specific genes on the triggers, has been very important. I mean, to realize that the conditions which are relevant to the onset of arrhythmias can be specific according to the gene has led to gene-specific management. I mean, this was probably one of the big things that we did at the end of the 90s, when my group proposed, for instance, the use of mexiletine for LQT3 patients, and now also for LQT2. But also it has guided management. For instance, as an example, the realization that patients with the so-called LQT2 type are at greater risk when they wake up in the morning, in the first few hours, if there is a sudden noise or something like that, has led us to suggest that the treatment with beta blockers, instead of giving them once a day in the morning, for LQT2, we give it morning and evening, so that we try to keep a higher level, higher therapeutic level also in the morning. So there are a number of ways in which genetics have impacted, and they can still impact a lot.
So I'd love to come back and talk to you about those in a second, but I'm just going to hand back to Filippo maybe to pick up on a few more of the broader elements of what it is that makes you Peter Schwartz. Filippo.
Well, Peter, is really a fascinating story. And what is impressive is that all stems from a clinical observation. I mean, it was that particular patient, that particular ECG clinical observation leading to clinical research. And I think this is a very important message for our young colleagues in particular, because we are flooded by artificial intelligence, scores, and fancy imaging, but we tend to forget that our main device is our brain. And when the brain works well, as in your case, then really results can be remarkable. Perhaps you can comment on scores in particular.
You touched on a very important point, because again, I regard myself as being very, very lucky in all my scientific career. But that was facilitated by the fact that since day one, in terms of my getting my MD degree, I was dividing my time between the clinic and the experimental lab. And the clinical setting, the patients were and are providing the questions, even now. That is the most important source, is the question that you have to face when dealing with patients. But then you need the next step. And either the laboratory or the now genetics and everything that goes with that is where you try to answer the questions. So again, I regarded myself as very fortunate because I had the opportunity to see the patients, realize the problems, and then within a few hours moving to my experimental lab, working with either cats or dogs, and then try to get the answers. For example, Perry was asking about the important moments in my story. It was not only the reproduction of two abortages at one point, but a few years later, when I started looking at the impact on the threshold for ventricular fibrillation by interfering with the autonomic nervous system, I remember the incredible excitement of realizing that by blocking the left cardiac sympathetic nerves, the threshold for ventricular fibrillation would increase by 70% or more, which meant that taking away these nerves, it will be more difficult for a heart to fibrillate. And that, of course, has implications that go well beyond long QT syndrome. In a sense, any condition where patients have a high likelihood of developing ventricular fibrillation, removal of these nerves can be very protective, simply because by blocking the release of norepinephrine in the heart, this is preventing the onset of ventricular fibrillation. And this still leaves open the possibility of drugs and even an ICD.
Peter, another important person in your life has been Peter Schwartz. This is the translation of your name in Dutch. Has been the second important person in your life after Agostina, but he lived 200 years ago. Why is a person who lived 200 years ago so important for your career?
Well, this man, Peter Schwartz, arrived in South Africa in 1690, at the time when there was a so-called Company of the Indies. I mean, the Dutch were using South Africa as a basis to move to Asia and to purchase all the things they were interested in. Now, this man stopped and started working in Stellenbosch, and he had long QT syndrome, type 1. We've been able to trace together with my partner in Stellenbosch, Professor Paul Brink, a very dear friend, the story of this family, because over 330 years, the members of this family have multiplied. Now we are following almost 500 members of those families, of the initial family, and almost half of them have long QT syndrome type 1. Now, when I heard about this in the late 90s, I realized that that was a fantastic opportunity to study what we call modifier genes, because we could have been dealing with a large number of individuals all having long QT syndrome and having the same identical mutations. Now, we knew that 80% of them were with symptoms, cardiac arrest and sudden death, but 20% had no symptoms whatsoever, despite having the same mutation. So that led on one hand to our building a house in South Africa and spending 3 months there with funding from NIH for 10 years, so $7 million, but led especially to my interest in modifier genes, which expressed simply, you could imagine it this way. Why is it that within a family with a genetic disorder, you have two siblings with the same mutation, one who has syncope, cardiac arrest, and dies suddenly, and the other one has no symptoms, nothing? Why is that? We believe that this is depending on other genetic variants that we call modifier genes. So Peter Schwartz, the Dutchman, was important to me because it led to his cooperation in South Africa and to my research, which is still ongoing, on modifier genes, which I believe are a key for a more selective risk stratification and for a more specific management of the disease.
Okay, so the fascinating story continues. All started with Agostina, then Peter Schwartz has opened a new avenue regarding modified genes. But now this recent interest, because you never rest on your success, you're always very productive. And one of your recent interests are inducible pluripotent stem cells. Now, can you summarize for our audience why is this technology so important and why so important in particular in your field of interest?
Yeah, well, the technology was derived by Shinya Yamanaka, who got 12 years ago the Nobel Award, because essentially enables all of us to take blood, taking blood cells, and to transform them in pluripotent stem cells that can then be differentiated in cardiomyocytes. So at the end of the day, or say end of the day, but it takes almost 1 year, you end up with the cardiac cells of your patient that contain exactly the same genetic background. Then we can do cellular electrophysiology and study the responses of the cells of our patients to a variety of drugs, to a variety of stimulations. This is a fantastic way to explore new therapies, for example. So when I realized that, I expanded my group in terms of developing the area of cellular electrophysiology. We have a fantastic lab for that. So practically, we go from the patient, from the traditional genetics, to the development of the stem lines and to cardiac electrophysiology, which again, I think is opening a very large number of possibilities.
Thank you, Peter. I remind our audience that you can ask questions. So please, if you have questions, we are happy to involve you in our discussion. Peter, let's come back to your life. In one of your papers, I noted an interesting sentence. You wrote, "Shyness has never been my weakness." What is the lesson for our younger colleagues? And why are your recommendations? What are your recommendations for them? I mean, this is an interesting, intriguing sentence. Can you tell more about it?
Okay, but by that I meant when I wrote it that I was never afraid of dissenting from powerful people, be they the directors or whatever. And there is one anecdote that I like to share with my students because I think it was informative. When I was only 30-year-old in January 1974, I had just arrived to work for 3 years in Galveston, Texas. One day I went to New Orleans to talk and meet with Dr. George Birch. Birch had been the very famous editor of the American Heart Journal for about 30 years. Very difficult man, rather aggressive. So I was allowed to sit down with him and he said, "What are you doing?" I tried to tell him the story of Agostina and say that one day I've seen an extremely rare phenomenon, T-wave alternates. And I gave the figure to him. He looked at the figure and said, "Rare, I've seen it hundreds of times," and throws the figure on the table. Now you're 30-year-old in a foreign country, what do? You take your figure and disappear. But as I said earlier, I had read everything since 1920 through 1970. So I knew everything on that very little topic. So I looked at Dr. George Birch and said, "You are wrong, I don't believe you." And then he started looking at me with big eyes. And I added, "Probably you've seen QRS alternates that is much more common." Eventually, you look at the figure again, and after what looked to me as an eternity, he said, "You know what? You are right. I was wrong. Why don't you start all over again?" He kept me there for 2 hours. And 1 week later, he invited me to write the first review article on long QT syndrome. And that was really a turning point in my career. And it was all dependent on the fact that on one hand, I knew everything on that little topic. Second, I was not shy. And I told him, "You are wrong."
Fascinating. Well, now our audience is asking questions. In particular, I can read a question from Aris Papadopoulou, who is, I think, can ask this question directly. Is Ari there? Aris, are you there? If not,
yes.
I can.
Yes, I'm here, sorry.
Oh, yes.
Yes,
Aris.
hi. Hi.
Please.
Thank you so much. Such a very exciting discussion. I couldn't resist, but I'm very interested in modifier genes. And I was wondering whether the ones that you're looking at are mainly protein coding genes or there's anything from the non-coding genome.
They're both.
Okay.
And,
where do you think is where is the balance towards?
well, I would put it in another way, if you don't mind. We are really in a learning phase. We are discovering more and more modifier genes. And now we are beginning also to understand their mechanism of action, which I think is the most fascinating thing. We had a paper on that in cardiovascular research, because in the moment we start understanding how they work, these can help us to design new therapies. So the main issue is to be certain that certain variants can indeed have an impact in modifying the outcome for the patient. And then you take it from there. But again, it's I've been working on it for only 20 years. So in the next 20 years, we'll find more.
Peter, I have another question before coming back to Perry. In your life, you've been in touch with many important colleagues. Which collaborations have been the most important in your life, perhaps starting with Alberto Zanchetti?
Collaborations have been very important in my life, without no question. There are two, though, that were very important. The first one was with Buzz Brown, a basic science physiologist who always published in Science in Nature. He used to come at the end of the 60s to work in Alberto Magliani laboratory. And on the first day of his visits, very young, we were 25, 26, 27-year-old, were making a proposal for a project for that summer. One year, one of my colleagues, his name was Massimo Pagani, proposed a project that was very complex, a lot of biofeedback systems. And when he ended, Buzz Brown said, "So what?" And there was a dead silence. I mean, because the guy couldn't answer the question about what is it. And then I remember I told myself, you should always be able to answer this question when you design a study. So what? I mean, what is going to be the result? The other partnership that was very important was the one with Art Moss. Art Moss was not an easy person to deal with. We had a number of good moments and bad moments, but it was a critical partnership because in 1977, we sat together at the ACC meeting in Vegas, and we decided to start the registry, International Registry for Long COVID syndrome. During breakfast, Art Moss asked me, "Peter, for how many years should we try to have this registry?" And I said 25 years, which per se indicates how young we were in those days. And we actually continued that registry for 25 years. And that has provided fantastic information that was not available at the time about the natural history, a response to therapy, by getting the very large families with a complete pedigree about affected and unaffected. This provided the geneticists with the essential tools to develop the screening for genes subsequently. So these two partnerships were certainly fundamental. I was lucky having many more, but these are the two that played a major role.
Well, this is very important because networking and public relations, if you want, in science are very important. And this networking eventually is very productive. But I read another question, Perry, so I'll come back to you just a second. I read a question from a colleague, Philomine Guemo. Peter, our audience is really global from one continent to another. And the question is about translation from inducible pluripotent stem cells towards the clinic. Is a big gap. Do you think that this big gap can be filled quickly? This is the sense of his question.
Yes, we actually already started doing that. I mean, Already several years ago, we demonstrated that in IPS from our patients, especially from patients LQT2 with a trafficking defect, there is a compound that is used for totally different clinical conditions that can correct the trafficking defect. So you observe that first in our cardiomyocytes from our patients, and then we started a clinical trial, which is ongoing, in which we get patients with this specific condition, which means a trafficking defect and LQT2, and we are following them for 1 week in hospital with this compound, and we are getting some very interesting results. The study is ongoing. I can't say much more than that, but that I think is a good example of using the IPS technology to identify and then test in humans this possibility for those patients, not many, who fail with current therapy. But I think it's important, Filippo, that we all keep in mind that independently of all the exciting new possibilities, what we are doing now is already very good for the patients. The treatments we have, which are not new, I mean, we're talking of beta blockers, sympathectomy, the old sodium channel blocker, mexiletine, are effective in the vast majority of patients, and there is a small number that may require an ICD. But with that, I mean, a disease that can kill, without any question, is really under control.
Thank you, Peter. When you ask written questions, please also say where you come from, your country. Perry, back to you.
So, Peter, I just want to take that last point. Oh, first of all, can I ask you, has anybody told you that you were wrong?
That's it.
And are they still alive? I would never say that to you, Peter, but you've always passionately believed that long QT syndrome is a treatable disease in the way that you've just described. But there must be some unmet need. There must be some frontiers in the management of long QT syndrome that we still need new solutions for. I mean, what are those in your view?
Well, I think the most difficult issue is to deal with those infants who have cardiac events in the first year of life.
Right.
We realized about 15 years ago that this group is very difficult to manage, is not well protected by what we have now. These infants, I said once when dealing with my first patient with a calmodulin mutation, I said that these infants are not meant to live. And what I meant was that without an ICD implanted in a 3-4 months old baby, they would have been dead. But as a matter of fact, we need to do much better than that. So we need to find appropriate therapies that do not result in shock all the time for this group of patients. There are not many, but these are very difficult patients. It is a struggle to keep them under control. And it's a difficult battle also because we have to imagine the pain in the families. I mean, often we're dealing with young parents, a first child, and it's a difficult situation, but this is a big challenge. This is where I would, we are spending time on that without any question.
Another question for you. The beta blocker story is unequivocally true. I mean, you can dramatically reduce events. But when we look at the event rates, particularly in long QT2, for example, there is still an annual mortality in that group. And when we're dealing with young people, have we really thought about what acceptable mortality is for this disease? And where I'm coming from on this, I think it's something we do very poorly in cardiology, where we have a paradigm for coronary disease or for heart failure, or in my world, in cardiomyopathy. But when we think about the absolute risks, we're often talking about very different ways of thinking. And long QT syndrome, the vulnerable period is in teenage years, the young adults. What is an acceptable mortality, residual mortality?
I'm tempted to say 0, but I know that exists. Now, as I said, one should keep separate the infants with symptoms in the first year of life. So they are a different story. For the others, I might have been lucky, but I mean, the last patient I lost, and we see, I mean, at my place, we have 6, 8 families every single day. And the last patient that I was following who died was 35 years ago. It was a patient who refused to take beta blockers. So he was not treated because of a direct refusal. I think that if you see the patients regularly, I think a key issue in the management is to do what we do, which is to see all of our patients once every single year, because the risk changes. It's not a stable risk. To assume that you see a patient for the first time today, you can assess risk and then forget about it and just send the patient away is foolishness. The risk is changing, and we need to adapt our therapies to the change in risk. If we do that, improving and modifying the therapy according to the risk that is changing, mortality can be very close to zero. Again, I was lucky having a zero mortality for 35 years, but I think that's not an unattainable situation. Of course, you have to use everything. There are many situations where people just go from a syncope on beta blockers, which is a partial failure, partial because the patient had an event but didn't die, to implant an ICD. And now to implant an ICD also conveys a lot of significant problems. So sometimes people are hesitating between the two. This is the area where using left cardiac sympathetic denervation reduces further the risk. And then, if necessary, you can still implant an ICD, having the sympathectomy to prevent the arrhythmias, and the ICD is a safety net, but with minimal concerns because the patients don't start having arrhythmias. So I'm not pessimistic at all. I think that this is a deadly disease when it's not well treated. If it is treated carefully, with passion, because you have to take time with your patients. For instance, I'm lucky because since I don't do private practice, I spend with the patients and their families all the time that is necessary for that family, explaining the questions, explaining why the disease is dangerous, what could be done and what should not be done. And then I think the results pay because these patients do well, and they can have, most of them can have a practically completely normal life, with some exception for competitive sports, perhaps, for some of them.
Yeah, I think that's a really important message. But Peter, if you look at what's happening in the world at the moment of gene therapy, I mean, there's a lot of excitement in inherited cardiovascular disease more generally. I mean, I've had more conversations with developers of new therapeutic approaches in the past 3 years than I had in the previous 30 years. But in the specific instance of long QT syndrome, given what you've just said, do you think there's a gap there for gene therapy? For could we imagine cure of the disease non-pharmacologically?
We all like to dream, and we also tried years ago to silence a mutation in rats and so on. I think it's a fascinating area, something that needs to be pursued because it has the potential of becoming very useful. I think it's also fair to distinguish between what is very attractive from an experimental point of view and the research point of view, which must be pursued because that is how progress is made. So that's a fundamental area. On the other side, we have to be careful in assessing what are our results now, because with our almost all the therapies, we are doing so well and in a safe way. So gene therapy also, I think it has to be will be implemented at one point, especially for those cases that are not well protected by traditional therapies. Because if I have a son or a grandchild with long QT syndrome, I would like to make sure that we don't deal only with the efficacy of therapy, but with safety. Safety is extremely important. So, I think we should pursue it carefully, without jumping onto it, and realizing that we already have very effective therapies.
That's a really important point. A question I was going to ask you myself, actually, but the role of mexiletine in the management of long QT syndrome. I'm still not very clear on that myself, to be honest. I mean, Peter, what's your view on this?
Well, the mexiletine story really goes back to the end of March in 1995. I mean, I was shocked on a Friday night when I was in Switzerland to ski by learning that on Monday, Cell would have published 2 papers on the genes. And when I read them, I was shocked because I thought that all my previous work would have looked like Stone Age work. So I had to do something and learn about genetics and how to survive in the new era. But when it was clear that one of the subgroups was related to an excessive inward current of sodium, well, I mean, it seemed natural to me and my sources to think, well, a sodium channel blocker could be useful. So the first thing we did was to call a family with the sodium channel mutation. We had 3 of them. We gave them mexiletine by mouth, and within 2 hours, the QT shortened dramatically. So remember that we sent in an abstract to the EHJ, and my colleague said, how can we send an abstract with 3 patients? And my reply was, you don't understand that this is the first gene-specific therapy. And things went on since then, and other people start using it. And it's clear that it's very effective, at least in shortening the QT interval. I mean, I've always wanted to distinguish between a purely cosmetic effect and a therapeutic effect. But as a matter of fact, when the QT shortens by more than 50 milliseconds, then you're also having a biological effect. And then, with some surprise, we found that also 2/3 of LQT2 patients respond rather well, which is less easy to understand, but this is a reality. So that's an important plus.
Okay. Filippo, I'm going to hand back to you in a second, but I just picked in one of my concluding remarks. When you started this conversation, I think you illustrated that importance of the link between the clinic and the laboratory. And I just wonder, do you think that link has been weakened as time has gone past? I mean, we live in an incredible time. We have amazing technology, amazing computing power, amazing understanding of molecular biology. But what do you think has happened to that link between the patient sitting there and what we can achieve technology?
It's a very sad situation. I think the link has been lost largely and at the beginning because people stopped working on the large animals, big animals. And if you don't work on big animals, then you lose the fact that the cardiac is an innervated organ. The autonomic nervous system plays such an important role. In the moment you move to cells only, you lose completely that very important pattern. And what was happening in the past was that cardiologists like me could also do experimental lab and assess in the lab their ideas. Now things are very different. The cardiologists just do clinical cardiology, basic scientists just do that. There is a very little crosstalk. The cardiologists, the clinical cardiologists don't know how to tackle the problem in the lab, and those in the lab have no idea about the clinical problem. So to me, it's a sad situation because what is being lost is this contact that Filippo was alluding to between the clinic and the lab, which in order to really make a progress for our patient, I think is a very important issue.
Filippo, back to you.
I can read some questions from the audience. There is a question from Emanuela Locati. Emilia, can you unmute? Please, Emanuela, ask your question.
Ciao, Peter. It's a pleasure to hear from you the long story and the adventure for the discovery of long QT syndrome that I shared in part in the past. Nowadays, we have this new observation that epicardial ablation might have a role in a very high-risk patient with this study we just made, where right ventricle ablation eliminated arrhythmias in very high-risk patients with a current ventricular fibrillation. So I would like to hear your opinion about this and if this finding might fit with your original hypothesis of the right-left imbalance being among the important atrial heterogenetic mechanism in long QT syndrome.
Well, are you asking about the ablation? Is that what?
Correct, yeah.
Yes, with the ablation, with the epicardial mapping, it was discovered that patients with very severe long QT syndrome may have a very heterogeneous potential duration on the surface, on the epicardial surface. And this could be at the core mechanistic mechanism for arrhythmogenesis in these patients. So I wonder where this might fit with the original hypothesis of, in fact, the right to left imbalance in this patient being among the clue of this disease.
That hypothesis has never been proven, so we'll have to keep it as a nice memory. It gave ideas for a number of studies we made, and that was important. But we have no real evidence of a developmental imbalance in the autonomic nervous system. What is clear is that if you cut the nerves at preganglionic level, you have a completed innervation, there will be no reinnervation, and that is very useful. One has to be very careful if you work on postganglionic nerves, because if you, for instance, do an ablation at pericardial level, for instance, then you do remove the postganglionic nerves, which may have a temporary effect, but over a couple of years, these nerves will grow again and reinnervate. So I think one has to be very careful with this type of procedures. Thank you for the question.
Thank you, Peter. Very clear. We have one last question from Massimo Volpe. Can we unmute? Massimo is our one of our editors, and please, you can ask your question directly.
Ciao, Peter. I find you very well. Listen, my question travels from your laboratory in the Physiology Center in Milan and the new technologies today. Do you have any chance to look at the impact of renal denervation on people with long QT? This is just a curiosity more than
no. Yeah, and I don't think we'll do that. I must confess that I've always been a bit skeptical about renal denervation as a way to protect the heart, because after all, that is a rather indirect way. I mean, if you, it's difficult to imagine that by interrupting afferents from the kidney, which lead to a reflex activation, you can have something more powerful than directly eliminate the efferent sympathetic nervous system. So I still go by the simple and very direct approach of eliminating the left side first. I mean, from the lower half of the left side ganglion down to the forethoracic ganglion, which eliminates the release of norepinephrine in the heart on the left side. And for a few patients, if that is not sufficient, then we go bilaterally and make also the right sympathectomy. That is very seldom necessary, but sometimes we had to do that.
Thank you, Peter. In life, there is much more beyond long QT syndrome. Something which is definitely more important is golf. And I've never understood what is more important in your life, long QT syndrome or golf. We also published on golf, the European Heart Journal. So I wonder, what is more important in your life?
More important is bridge, but I will explain my result in a minute. First of all, I published on golf in European Heart Journal, as you say, but I also published on golf in The Lancet and in Circulation.
But I was quoting the most important journal.
Well, I always do. I need to check my impact factors. Golf is important to me because it's a competitive game where you compete against yourself. So it's a technical game which takes you out for several hours. When I play in a tournament, I can clean my mind because I don't think of anything else but playing as well as I can, which is not very good, but decent. And golf again is lovely because you compete against yourself. But your question was, is it research or golf? And my answer was bridge, because the real truth, my real passion is playing bridge. My father was a medical doctor, was one of the top bridge players in Italy. And the challenge there is that I know very well that I'll never be as good as my father in playing bridge. But bridge is what I know that I could play until my last day. I mean, because you see, before playing bridge, I was a chess player. I mean, my story really was playing chess. I like to play in general. but play is important in life. I started with chess, bridge, and biomedical research. And the three of them have something in common. It's all problem solving. And this is what fascinates me, to solve a problem. Clearly, to solve a biomedical problem is more socially acceptable than solving a bridge problem or a chess problem. But they are all three significant games that keep your neurons active in your brain.
Very clear. Something to keep in mind, important message for our colleagues, younger colleagues in particular, how to stimulate our brain, which remains the most important device in our daily life, more important than artificial intelligence. Peter, you're also a successful editor of the European Art Journal. How can we improve the journal?
By not changing is the first rule. The journal is excellent. You should do on as you are doing. The main message is not to fall prey of the need of accepting articles. So if an article is not good, it should be rejected. Sometimes this may lead to a relatively small number of accepted papers, but more than improving, you should make sure that there is no worsening. I mean, you're already doing an extremely good job, Filippo. So keep going in the way you're doing. Simply make sure that if a paper does not meet the standards of the journal, it should not be published.
Yeah, well, this is a tough lesson for the authors who are going to submit to the European Art Journal, but this is the case. I mean, we want to publish top science, but we also want to involve our readers and our authors live today. I think that in addition to printing, to publishing top science, it is important to create this community, this common feelings among editors, authors, and reviewers and readers, as we are doing together. So definitely we accept top science only, but the world of cardiology is wider than top science, and the journal wants to play a role also in creating this community. Well, we are at the end of our dialogue. Perry, thank you for hosting Peter. Peter, thank you for your fascinating story. The successful story of the dialogues continues. Next dialogue will be, as usual, on the last Thursday of April, will be April 27th at 17 Central European Time. Thank you again for this brilliant, pleasant, and instructive hour. Bye-bye.
Thank you. Thank you very much.
Thank you, Peter.
Thank you, Perry. Thank you, Filippo.